Good morning, everyone. This is Chris back again with The Ancient Scholar, and we'll talk about something a little different, a little not necessarily unrelated to respiratory therapy, chemistry, and so on, but certainly it is quite related to that, just in a different way. And what this is in response to is a question that a family member of mine asked. He's actually in a water science program. And they have to do, so there's some math requirements they have to complete for this program, and he was, apparently some other people in his class were stumbling on some of the concepts, and it wasn't necessarily that there was a problem with their ability to do math, to add, subtract, multiply, divide, and so on. It really, I think what it comes down to is a failure of logic and intuition, and that we just sometimes aren't able to intuitively or logically figure out what in the heck a question is asking. So I'm going to just introduce everyone to the concept of conversions and something known as the dimensional analysis, or the type of dimensional analysis that we typically use. And it's very important because this kind of math makes the world go round, so to speak. Well, actually, we know that calculus is what makes the world go round, but figuratively speaking, this is kind of some bread and butter of mathematics. So I thought I'd just spend a little time talking about it, maybe even do a couple of videos on this. So what I'm going to do is I'm just going to start off with a problem. And the problem goes like this. This is related to one of their homework assignments. It's not the exact numbers that they have on their homework, but it is a number nonetheless, and the math is still the same. And the problem goes like this. I have a water treatment plant, and every day 100,000 gallons of water goes through that plant every day. So every 24 hours, 100,000 gallons. And the question asks, well, how many pounds of water goes through the plant a day? So the first thing we need to understand or recognize is, what are they asking? They're asking us to convert. They're asking us to take 100,000 gallons and convert that volume, because a gallon is a measurement of volume, convert that volume into a weight. So what we need to do is we need some sort of factor to help us with this conversion. And you go and you look in the book, and you'll find one, and I'm going to presume that they're using US gallons here. 1 US, because you have different type, imperial gallons and so on. 1 US gallon weighs approximately 8.35 pounds. Sorry about that little pause there. I was actually going to put liters in there to convert a gallon to liter. That'll come later. So again, it's really important we know what units we're dealing with. Alright, so 1 gallon weighs 8.35 pounds. And I'm not sure, as far as the water technology, how many significant digits they want you to take these calculations out. Generally speaking, 3 significant digits, 8.35, is going to be very accurate for most of the things that we work with on the macroscopic world. Okay, so this is our conversion factor. And now how do we make sense of all this? Well, here comes something known as the dimensional analysis. And this is what I do. I set up 2 conditions. I have condition A and condition B here. Condition A is what I know absolutely to be true. And what I know absolutely be true is this right here, this factor. I know that 1 gallon of water equals, so gallon on top, equals 8.35 pounds. I know that to be a fact, and that is an axiom, a self-evident truth right there. What I need to know, so condition A is what I know, condition B is what I need to know, is how much this weighs. So if I have a gallon on top, I need to have a gallon on top here. And this is 100,000 gallons equals, I don't know, X pounds. I don't know. So now we've got the formula set up. It becomes incredibly easy to solve. All I do is I simply cross multiply here and here. So this is 1 times X. So down here I'm going to have 1X equals 8.35 times 100,000. 8.35 pounds times 100,000 gallons. Okay? So then I go ahead and pull up my little calculator here, and I just do the math. So 8.35 times 100,000 equals 835,000. And if you were really good at moving decimal points around in your head, you wouldn't even need a calculator to do this problem. So I know this X equals 835,000 what? Pounds. I don't need to do anything with this 1 there, right? Now if this was a different number, I would have to divide both sides by that number, but I don't in this case. So X equals 835,000 pounds. That is the basic way to work through conversion. It may look a little mathy, and certainly once you get better at this, you'll realize that you really don't need to do this formula every single time to make a conversion. But when you're first starting out, it's nice to have a structured process that you can do that will get it right every single time. So certainly I'd urge you to kind of try this because it works every single time when you're doing your conversions. Okay guys, I'm going to cut it here, and I'll probably end up doing a few more problems, a few more conversions, and we'll get a little more advanced. But that's the basic conceptual, these are the basic tools that you'll need to work through all these problems. And this doesn't necessarily only apply to water technology. This math right here is actually the basis in medicine, in respiratory care, nursing, and paramedic school. I would presume a dental assistant in hygiene, and maybe even x-ray technology where they have to give radioisotopes for certain imaging. This is the basis for how we find out how much of a drug to give somebody, or medication calculation. So a wide variety, a wide range of applications with conversions and this concept known as dimensional analysis. Okay guys, thanks a lot. Bye-bye.